So, okay, Gurmeet, so I think you got some concept about functions now,
Yeah.
right?
Yeah.
Now let's talk about sketching the graph of these functions.
Okay.
Right. So, as you can see, the constant function which we are talking about is just a horizontal line.
Yeah.
A linear function will be a diagonal line which will kind of cut the coordinates into equal halves, right?
Yes.
Diagonally, right?
Yes.
And the parabola will be symmetric to y-axis,
Correct.
right? Kind of being from quadrant 2 to 3. The cubic function will go from quadrant 3 to 1, right? From 3 to 1 like this.
Yeah.
Symmetric about the
Origin.
And the quadratic function, which is x to the power of 4, will be like a parabola, but flatter here, more flatter here, right?
Right.
So, and then going up like a parabola.
Okay.
But if we have degree 5, it is like a cubic function again, but flatter here and going like this.
Yeah.
So what do you notice? You notice that all the even degree functions, basic, are symmetric about the y-axis.
Right.
And all the odd degree functions are symmetric about the
Origin.
And what you also notice is that all these x to the power of 3, x to the power of 5, 7, 9 and so on, they kind of flattens here and then move forward. Like we call this shape like a tilde. Right? So they come like this, they think whether they have to go up or they have to turn, but they have 3 zeros. First zero is telling them to go up, like a straight line.
Yeah.
The second one is telling them to turn. And the third one tells, no, move forward. And then they move forward like this. So that's the kind of shape you get for a cubic function. So when we sketch polynomials, keep in mind that we could have different kinds of zeros.
Right.
So we could have a 0, which is kind of a linear. So it is going to cross the x-axis like a line.
Right.
But if we have a 0, which is kind of quadratic, let's say power 2, 4, 6, 8, any even power, it is going to turn like a parabola.
So whether it's going to turn, because there's different terms in polynomial, right?
Yeah, yeah.
So whether the equation, according to the equation, the graph will turn or curve, does that have to anything with the exponent of that term?
Yes, it does. It does. So what we see here is, if first we should write the polynomial in factored form.
Right.
So once we do that, we get all the zeros in place.
Correct.
Each zero, we have to identify the degree of that zero.
Correct.
Rather, we actually say multiplicity of that zero.
Okay.
Or the order of that
zero.
Right. So I'll make a video with you on multiplicity of 0 and difference between 0 and x-intercepts also, where I'll explain you better this concept.
Okay.
But for now, you can think about each factor having something as a power. So power could be 1, 2, 3, 4,
5.
even or odd.
Yeah.
Basically. If it is 1, we say it's a linear kind of
so
a
just
0.
straight.
So it will cross the x-axis at the x-intercept like a line.
Right.
But if the degree is even, it will turn at the x-axis point, right?
Right.
But if it is odd degree, it is going like this, thinking whether to turn or not and then moving forward. Right? Does it make sense to you?
It makes sense to me.
Does it make sense to you? So this is the first part. So whenever you're given a polynomial, break it down into its factors and write it in the factored form. So that's the first step.
Okay.
So I'll put up an exercise for you where we'll have polynomials in factored form and you need to sketch them, right?
Yeah.
Now, second important thing to sketch a polynomial graph is to look into its degree.
Right.
You know what degree is for a polynomial?
Yeah.
What?
So the highest degree that you have.
Yeah, the highest degree. But when I write it in factored form, you have to add the powers, the exponents of all the factors to get the degree, right? Now, one thing is the degree, which is important. The second thing, which is very important, is the leading coefficient.
Right.
And we have to only see whether the leading coefficient is positive or negative.
Negative.
Right, that's it. As you remember, if it is x squared, graph goes upwards.
Correct.
But minus x squared flips it over, right?
Right.
So it ends up in quadrant 4, the minus x squared.
Yeah.
But x squared ends up in quadrant 1, correct?
Yes.
So leading coefficient is actually making that switch.
Okay.
So what we see here is that if the leading coefficient is positive, then for a polynomial, it will always end up in quadrant 1, right?
So does that affect the even or odd of it?
Not for the ending portion, but yes, it affects the odd and even affects the starting portion.
Right.
So when you see a graph of any function,
right,
you have to see it from left to right.
Right, correct.
So on this, our axis, here x is going towards positive infinity. On this side, it is going towards the negative infinity. Right?
Yeah.
So if the leading coefficient is positive, all the graphs will land up here in quadrant 1. They're going towards infinity like this. That's the end behavior.
Okay.
So we call it end behavior.
End behavior.
It's a new term for you again, right? So end behavior is when x approaches positive infinity, what happens to y? Now in this case, for a polynomial, if the leading coefficient is positive, then y approaches positive
infinity as well.
Right? Now let's think about a polynomial with even and odd degree and leading coefficient positive.
Okay.
Now, if the degree is even, then what happens when x approaches negative infinity? Like a parabola. Think like
It ends up in the same.
it ends up there in quadrant 2.
2.
So both sides are up. Do you see that?
Yeah.
So for an even function, both are on the same side.
Correct.
And if the leading coefficient is positive, degree is even, both are up.
Up. Correct.
But if the leading coefficient is negative, both are down.
Down.
It gets flipped. Do you see that?
I see that.
Right? Now, if the degree is odd degree, then, well, the right side remains up.
Up.
It is in quadrant 1.
Yeah.
However, the left side is on the opposite end.
Oh.
So when x approaches negative infinity, y approaches negative infinity, right?
Correct.
So when x approaches negative infinity, y approaches?
Negative as well.
Yeah, negative infinity.
Yeah.
So for an odd degree function, leading coefficient being positive, the graph will be moving from quadrant 3 to quadrant 1. But for even degree function, it moves from 2 to 1. So do you see that?
I see that.
So from the leading coefficient and degree, if you are given a graph, you can recognize which graph corresponds to what. Right?
Okay.
So can you summarize this for me, please?
So these are just tiny tricks. So we looked at polynomial, how to graph. So we have certain things to consider. So with that comes the leading coefficient. That's really important.
Yeah.
More specifically, whether it's to positive or negative. And that being combined with the degree of the polynomial, whether it's even odd, these factors would really determine how your graph is.
Perfect.
And for the even, we know that for even a degree, you have a nice curve, right? Because you have to put the equation in factored form, right?
Yes.
And then for odd, you would have like a smooth curve. So it just goes away. It doesn't know what to do.
Yeah.
So it wouldn't turn.
Yeah.
And these are some things that are important. And you have to also, when you look at n, I believe, you have to add the exponents, right? But then how about if there's a bracket, there's exponent in the bracket and also outside the bracket?
Multiply them. Use exponent rules, right?
Yeah.
So if I have x squared minus 1 to the power of 2, then the degree is 4.
Okay.
Right? You
Yes.
get it? That was your question, right?
Yes, that was my
Perfect.
question.
And also, if it is x squared minus 1, you have to split it into two factors, x plus 1 and x minus 1. Remember
Right.
that also.
Factoring, okay.
But however, if it is x squared plus 1 to the power of 2, we don't get a real 0.
Right.
Right?
Yeah.
X squared plus 1 is never 0.
0.
For a real number.
Correct.
Right? Okay. So could you just tell me that how will an even degree function with leading coefficient negative look like? What will be its end behavior?
It both be down.
Both be down.
Yes.
But if the leading coefficient is negative and the degree is odd, in that case, how will the graph be? Let's say this is my quadrant 1. Where will it move from? Which quadrant to which quadrant?
It would move from quadrant 2 to 4.
Quadrant 2 to 4, that's perfect.
Yes.
So that's the end behavior.
Correct.
So when x approaches negative infinity, y will approach positive infinity.
Correct.
When x approaches positive infinity, y will approach
Negative infinity.
When the leading coefficient is negative
And the degree is odd.
Well done.
Thank you,
Great.
sir.
I'm Anil Kumar. Welcome to my series on polynomial videos with Gurmeen. Thanks a lot, Gurmeen, for being a patient listener and a good learner. I really enjoyed creating these videos outdoors with you, and I hope you learn in the process. Here are 6 questions. We'll review the concepts learned. Mainly, we'll be talking about how zeros, leading coefficients, degree of polynomial help us to sketch polynomials when given in factored form. Here is question number 1 for you. Match each equation with most suitable graph. There are 4 graphs and 4 equations. I like you to think about how these are related and how we can match them. So let's try to analyze. Let's go by the equation. The very first equation is x plus 1 times x minus 2 whole square. The leading coefficient is positive. So we'll cite positive for leading coefficient. Degree is 3 for all, as you must have seen. So they're all cubic, right? Now, leading coefficient of positive means right up. So that means right side is up. So when I say right side is up, we are looking into these two options. Perfect. Now here we have 00 at x equals to 2, and that makes us option C, right? So A is linked with option C. Perfect. So it's that simple. Now let's look into B. This time again, the leading coefficient is positive. See, 2 minus x whole square. So when you square negative, it really becomes positive. So again, the leading coefficient is positive, right side is up, right? So, and in this case, the 00 is again at x equals to 2, right? So x equals to 2 and x equals to 1 is a single 0. So this also links to option C, right? So B also links to option C. It's kind of a trick question. I hope you understand and appreciate it. Now let's look into, so basically x minus 2 whole square and 2 minus x whole square is one and the same thing. Perfect, is one and the same thing. So that's a good learning. So sometimes you could have either form of equation to represent that curve. C, f of x equals to x plus 1 whole square. So that means 00 is at minus 1. And then we have x minus 2. Leading coefficient is positive, right? So x square and x, when you multiply, you get positive. So right side up, where 00 at minus 1. So right side up for 00 minus 1 is option B, right? Right side up, 00 at minus 1 is option B. So C gets connected with option B. Perfect. D, f of x equals to minus x plus 1 whole square. That means right side is down. Is it okay? Right side is down. 00 is at minus 1. So there's a turning point at minus 1, right side down. So D matches with A. Correct? So now we can write down all our answers, which is C. So A matches with C, right? And B also matches with C. B also matches with C. C matches with B. Let me write down here. C matches with B at minus 1 with A, right? So C matches with A. I mean, D matches with A. So is that okay? So that is how you're going to match the graph with the given equations. Correct? So there is no match for capital D. Okay, let's move on and take question number 2 now. In question number 2, we have given 4 equations and there are only 2 graphs, right? So these 2 graphs will match to only 2 equations. So let's try to figure out. Match each graph with suitable equations. So the first one, let's try to analyze this. We have right down, so right side is down. That means leading coefficient negative, right? So we say AN is less than 0 or negative, right? And we have 00 at 2. That means we have a factor which should be x minus 2 whole square. Perfect? X minus 2 whole square. So that means Negative means negative and x minus 2 whole square. That means A matches with capital A. Perfect? Right. Now let's look into this. Well, here also right side is down. However, double zero here is at minus 2. So we are looking for a factor which is x plus 2 whole square with leading coefficient less than 0. Right? So x plus 2 whole square we're looking for, which is option D, x plus 2 whole square, leading coefficient negative, another 0 at 1. Right? So another 0 at 1. So we have 0 at x equals to 0, x equals to 1, and double 0 at x equals to minus 2. So D matches with B, correct? So D matches with B and A matches with A. Perfect. So that is how you could match equations with graph. I hope that is absolutely clear. So here we have used the concept that if leading coefficient is negative, then right side is down. Means quadrant 4. Does it make sense to you? So this means both leading coefficients should be negative, right? As you have seen. Perfect. So that is how you match the graph with the equation. You can always match the other parts, which are the zeros, right? Question number 3. Sketch the polynomial function y equals to 3 over 8 x plus 4 times x plus 2 whole square times x minus 1 to the power of 5. So let's try to do it in simple steps. So we have this function y equals to 3 over 8 x plus 4 times x plus 2. That 0 has order of 2, and then we have at 1 order 5. So let us list all zeros first. Zeros are at x equals to minus 4, at minus 2, and at plus 1. Now what is their order? Order of 0 is 1, linear, this is 2, quadratic, and this is 5, right? Okay, so that gives you total degree. So what is the degree of this function? You can add these zeros. 5 plus 2, 7, and 1, 8. Here also 5 plus 2, 7 plus 1, 8. So that confirms that all this is correct. Is it okay? Now what is the leading coefficient? I'm writing an as my leading coefficient. It is positive, right? It's greater than 0. It is positive. Now what does that mean? It means that the right side is up, right? So we'll now sketch this function. So it is not to the scale, but it will make a lot of sense still. 8 means even and right side up, right? So the behavior is kind of like this. Do you see that? Now let's fill up the zeros in between. So we have a linear 0 at minus 4. Let's say this is minus 4. The graph will just cross at minus 4, right? At minus 2, it is order 2. So it's going to turn. So let it turn. So this is at minus 2. It turns. And at 1, it is of order 5. So it's going to go like this. Do you see that? So that is how you get your graph. Does it make sense to you? So it is a good idea to indicate the behavior of the curve at each 0 to begin with, and then connect, right? Does it make sense to you? Now, one important point is left, and that is the y-intercept. So we have to calculate what is this point, y-intercept, right? So substitute 0 to get y-intercept. So we have y-intercept as, if I substitute 0, I get 3 over 8 times x. X is 0, so we get 4, times 2 square times minus 1 to the power of 5. So you see this is negative value, so that is negative value, and here we get 4 times 4, 16, divided by 8 is 2, so we get minus 6 as our y-intercept, right? So y-intercept is at y equals to minus 6. So that completes your graph. Is it clear? Right? So that is how you're going to use all the information learned about leading coefficients, zeros, their multiplicities and order, and sketch the graph. Let's take one more example. Question number 4. Sketch the polynomial function y equals to half x squared. So double zero at origin, x squared minus 4 times 1 minus x whole cube. Now x squared minus 4, it could be further factored. Now this is very critical. So let's factor this. So we get half x squared. You could write this as x plus 2 times x minus 2. So we get two linear zeros here times 1 minus x whole cube. Now in this case, let's start with the order, or rather degree of polynomial. Degree of polynomial is 3, 1, 4, 1, 5, and 2, 7. Just add all these exponents, right? And then, well, let's talk about leading coefficient an. Now, leading coefficient in this case is going to be negative. You know why? Because of this minus x cube, it is going to be negative. So it is less than 0. It is negative. Do you see that? So we have odd degree polynomial with negative leading coefficient. How are you going to sketch it? Okay, so odd degree really means that opposite ends, and negative leading coefficient means right side down. So right side is down and opposite ends. Does it make sense? Right? So this really means opposite ends. And this means right down. So I hope the concept is clear, right? Now, we'll again write down all our zeros. So let's write down zeros now. So what are the zeros for us? At 0, the order is 2. So I'm writing in brackets at x equals to 0, order 2. Then we have linear zeros at minus 2, order 1, at plus 2, order 1, and at 1, order is 3. So these are the zeros. Perfect. So let's show them here. So we have 0 at minus 2. So negative 2 is here, let's say, which is linear. So the graph will actually cross. We have to go from left to right. Is it okay? And then comes 0. So 0, we are now on this side. So we'll turn at 0. So that is 0 turning point. So we've taken care of this and that. Now at 1, it is again turning. So let's say we go back and turn at 1. So we have turning at 1 also. But at 3, so at 1 is cubic. Sorry. So we made a mistake here. At 1 it is turning. So it is kind of turning like this, like a cubic. And at 2, it does like a linear function. So it goes kind of like this and then turns like this. Perfect. So let me redraw it. So it's a good idea to always first mark these zeros, right? So minus 2 is our first zero, which is linear. So it'll go down. It's like a straight line. At 0, we have quadratic 0, order 2. At 1, it is cubic, right? So it'll turn like this. And at 2 is again linear, so it'll go straight at 2, right? So connecting these, we get our polynomial graph. Does it make sense to you? So what you also saw here, that I nearly did a mistake by not plotting my zeros earlier, right? So it is a good practice to first clearly indicate the zeros and the behavior of the curve at those zeros or x-intercepts, and then connect to graph the polynomial function. I hope it makes more sense for you, right? So it's a good idea to write y and x and label it, right? Let's move on to question number 5. I hope you are enjoying the journey of sketching polynomial functions and you got the concepts. Feel free to pause the video now, solve, and then look into my solution, right? Question number 5 is, sketch the graph of polynomial function with given zeros. Then write equation of the function. A. So there are two parts to it, right? A, we are given the zeros. Let's write down. We are given the zeros as at x equals to -4, -1, 0. Now this 0 is of order 3 and then 2 of order 2, right? So these are the zeros. So let us sketch this graph. Okay, let me do it here. Okay, so we have 2 negative, that -4 is a bigger number. So let me draw y-axis here. So the first zero, start from the left side. Now, we could assume any leading coefficient that has not been specified, right? So you could draw many graphs for the same conditions, right? So many possible graphs. Okay, now let's begin. Let's think that we'll start from this left side. Is it okay? What is the degree of this polynomial? 2 plus 3, 5, 6, and 1, 7. So we see that the degree of this polynomial is 7, right? So this polynomial is of degree 7. So let's add. We have 1 plus 1 plus 3 plus 2, which is 7, right? Odd. So what I'm assuming here is that we'll do with negative leading coefficient. So we'll start from here and end the other end. Is it okay? Odd degree means opposite ends. Perfect? Okay. So -4 is the leftmost. So let's say -4, which is linear. So we'll just go down. Then at -1, again a linear. So we'll go up here. At 0, cubic. So we'll come down with kind of like this. And at 2, we are going to turn. Do you see that? So these points could be connected. And we get our graph. Perfect. So that is the first part. The second part is how to write equation for this. So the equation could be, we say f of x is equals to, this is at -4, so the factor is x plus 4. Now this one is at -1, so the factor is x plus 1. And then we have a 0 at 0 itself, so it is x cubed since the order is 3. Then at 2, we have a factor x minus 2 and the order is 2, so that's squared. Does it make sense to you? Right? Now, since we are drawn like this, leading coefficient negative, we should write negative here. Otherwise, this equation is wrong. It does not reflect your graph. So it should be negative since we have kept right side down. Does it make sense to you? Perfect. So that is how we do A. Now for B, I'd like you to do it yourself. The process is simple. First, list all the zeros. So the zeros are at -3, the order is 2. Then at -1, the order is 3. And then it is at half. If nothing is written, that means order is 1. Now what is the degree of this polynomial? Combine all these zeros. 2 plus 3, 5 plus 1, 6. So it's an even degree polynomial. Now we will assume that the leading coefficient is greater than 0. Perfect. Because that's the flexibility we have. Condition is not given to us, right? So if I say that it is leading coefficient is positive and the degree is even, then both are up, correct? Both side up. So let's begin with zeros on the leftmost. So -3. So here at -3, order is 2, so it's going to bounce back. At -1, it's going to go like a cubic function, right? And then at half, it is going to just cross like a linear function, right? Now, let us join them to complete the graph. So it could be like this, right? And now we can write down the equation of this. Let's say g of x is equal to, now this is the positive leading coefficient, right? So this 0 will give us x plus 3 as a factor, and 2 means square, right? Then we have x plus 1 cube, right? And then we have at half. Now how do you represent half? It is 2x minus 1 will give you half. Does it make sense to you? Correct? Now to be very specific, we can find what g0 is. So if I put 0 here, I get 3 square times 1 times 2, right? Times 2. So that gives us 9 times 2. I'm sorry, this is minus 1. I was just wondering. So if I put 0 for x, what do you get? We get 3 here, 1 there, and minus 1. So minus 9. So we get minus 9. So this point is minus 9 for us. Perfect. So that is how you get your graph. So I hope that makes sense. So let's move on and take up the last question now. Question number 6. Sketch the graph of polynomial function with given conditions. Then write equation of the function. A. Degree is 4, positive leading coefficient, 2 zeros and 1 turning point. Okay, so let's try to sketch this. We want to have degree of 4, right? Positive leading coefficient. Degree 4 positive leading coefficient. That means even degree. Positive means right up. So the graph should be something like this. Is it okay? 2 zeros and 1 turning point. So let's say 2 zeros. So zeros could be anywhere, but we need degree 4. So you have to decide. One of them could be cubic, correct? So we'll think about it like cubic and a linear 0 to make it 4, right? So let's say this 0 is kind of cubic. Let's say like this, right? And then we have a linear 0 here. Does it make sense to you? So connecting these points, we could easily sketch the graph. And then we'll write down an equation based on our sketch, right? So let's say this is how we are going to do it, right? So let us say this point is at minus 1 and that is at 2. In that case, the function could be, we have a cubic 0 at minus 1, so it is x plus 1 whole cube, and then linear at 2, so x minus 2. That is degree 4. Perfect. Now in this particular case, what is f of 0? If I plug in 0 here, I get 1 times minus 2, which is minus 2. So this point should be minus 2. Does it make sense to you? Right? Now the last question you should do yourself, and then let me know if all the concepts are absolutely clear to you or not. Feel free to write your comments and share your views, right? Now let me do it. Provide you the solution. Degree 3 negative leading coefficient. Odd degree negative means right down. Odd degree means opposite ends. 1 0 no turning point. And f of 0 is 2. So we have to be specific. F of 0 is 2. So there is one x-intercept here, right? So that is what is given to us, right? So it is degree 3, so opposite ends, odd degree, negative leading coefficient, right down, right? Right side is down. 1 0 no turning points. So we'll just say that this is kind of a cubic function, right? Going like this. Is it okay? So that makes sense. So that could be a very simple graph for this. At 2 itself, let's have our tilde type of a curve, right? So it thinks and then moves forward. So it could be y equals to x minus 2 whole cube. So that becomes your function which satisfies the given condition only if you write negative here. Do you see that? So don't forget to write negative. Does make sense to you, right? So x equals to 2 gives you that 0. And this negative leading coefficient makes it write down. Perfect? So I hope you have understood all the concepts. Feel free to write your comments and share your views. Thank you and all the best.